Alright, so next up we're going to have a look at the modulus of Z and what that means. So hopefully you've heard this before, but if not, we're going to have a quick look at it. So what is the modulus of Z? So the modulus of Z is the length of the vector. So that's this vector here from the origin out to this red dot here, now black dot. The length of that, and it's given by this equation. Alright, now the reason we get that equation is because we can break this up into a triangle. So let's go across here. Let's call this part A. And if we go down here, call this part B of the triangle. This is a right angled triangle, and the length is now the hypotenuse. So we can just use Pythagoras' theorem to calculate this. So this is basically just Pythagoras. We'll have an example of that now. So let's have a look. Find the modulus of Z, so the length of Z when Z is -3 minus I. So quickly again, it's good practice just to, if you're not sure, draw it out. So -3 on the real axis, and on the imaginary axis we're on -1. So 1, 2, 3 here. This is it, and the length of this is going to be, it goes across 3 and down 1. All right, so using Pythagoras, the length of our vector is square root of 3 squared. And you know what? We can actually do the square root of -3 squared. All right, as long as we put the negative in brackets. Plus, this is just an I. We know it's -1i, so 1 squared. Oops, -1 squared. All right, put that in. We're going to get square root of 9 plus 1. All right, these are always going to be positive numbers. So if you're getting negative, you're doing it incorrectly. You need to put the brackets around. So 9 plus 1 is the square root of 10, and we can leave it like that. So that is the modulus of Z, the length of our vector Z, and that's how we work that out. Thank you.